Okay, now I'm on number 11. Number 11 says that we have an AED, which is the thing that delivers a defibrillator. It delivers charge. We know the capacitance is 15 times 10 to the minus 6 farads, because that's a microfarad. We know that it's going to deliver a charge of 0.35 coulombs, and we know that Q is equal to CV. So if they want to know the voltage delivered, I'm going to take Q and divide it by C. So Q is my 0.35 coulombs, and C is my 15 times 10 to the minus 6 farads. So if I make that division occur, that's 23,333.3 volts, and that's why they stay clear, to make sure that nobody's going to get hit by that much voltage except for the patient. If it takes time of 0.002 seconds, what is the current delivered to the patient? Well, I is equal to Q. Oops, sorry, that should have been an I for current, not A for amps. So I is equal to Q over T. Well, we know the Q is 0.35 coulombs, and we know the time is 0.002 seconds. And so we're going to get 175 amps for the current. All right, then it wants to know, for question 12, you have two charges, 4.6 times 10 to the minus 6 coulombs, and Q2 is 3.2 times 10 to the minus 6 coulombs. And they're separated by a distance of 0.30 meters, and it wants to know what is the electric field midway between the 2 points. Well, I'm going to go ahead and put my Q1 and Q2. So I'm looking at part B, and it says, okay, this one's my 4.6. And over here is my 3.2. And so I want to know what is E right in the middle. Well, that's 15 centimeters away. So those are my R's. There's R2 and there's R1. So I'm going to say E is equal to KQ1 over R1 squared. So I have 9 times 10 to the 9th. And I'm going to use 4.6 times 10 to the minus 6 over 0.15 meters squared. And when I did that, if I did my math correctly, I got 1.84 times 10 to the 6th newtons per coulomb. And electric fields go away from positive charges. And then I did, so that was E1. Then I solved for E2. So I got 9 times 10 to the 9th. 3.2 times 10 to the minus 6 over 0.15 meters. And don't forget to square it. So when I did that, I got 1.28 times 10 to the 6th. And so that positive charge has a field in that direction. So I know since they're in opposite directions, I need to subtract those two values. So I just did a minus there, and when I did that, I got 560,000. And it's going to be in the direction of the larger, which is the one right there. Okay, then they want me to go to part B, and they want me to rework it. And this time they want to put the charges exactly like I had them. But they're going to change the R value. So this is going to be 10 centimeters, or 0.10 meters. And this is going to be 20 centimeters, or 0.20 meters. So I reworked E1, 9 times 10 to the 9th, times 4.6 times 10 to the minus 6 over 0.10 meters squared. And when I did that, I got 4.14. times 10 to the 6th. And it's away from this positive charge, so that would be to the right. And then I did E2, 9 times 10 to the 9th. .2 times 10 to the minus 6. And 0.20 meters squared. And so I did that and got 720,000. And it's positive, so it goes away from that positive, so that one would be to the left. Again, they're in opposite directions, so I simply subtracted them. And when I subtracted them, I got, I believe that looks like 3.42 times 10 to the 6th newtons per coulomb, and it's in the direction of the larger one. All right, so now we're going to look at number 13. Now it says, while cleaning, Jeffrey causes his lamp to acquire a charge of 4.5 microcoulombs, so that's Q. And I know that the field is 2400. So they want to know how far away is the chin from the lamp. So I said, well, E is equal to KQ over R squared. So R would be the square root of KQ over E. And I got a ridiculous R. So we should have adjusted some of those values so the R didn't come out to be so huge. But that's all right. Q is 4.5 times 10 to the minus 6 coulombs. And the force, the electric field, I should have said, is 2400 newtons per coulomb. So when I solved for R, I got 4.12 meters. All right, last two. I have a series circuit. And I have a 12-volt battery. And this is 6 ohms. This one is 15 ohms. And this one is 20 ohms. Positive terminal of the battery, negative terminal of the battery, 12 volts. So current begins to flow like that. So first thing you should always do is find your total resistance. Well, 6 plus 15 plus 20 is 41 ohms. Total voltage is the voltage from the battery. So total current is V total over R total, which is 12 volts over 41 ohms. And when I did that math, I got 0.293 for my amps. Well, that's also I1, I2, and I3. So you can fill that in on your chart. Then V1 is going to be I1R1. So V1 is going to be 0.293 amps times 6 ohms. And when I did that, I got the voltage to be 1.76. And then V2 is going to be I2R2. So 0.293 amps times 15 ohms. And when I did that, I got 4.4 volts. And then V3 was I3R3. And when I did that, I got 0.293 amps times 20 ohms. So that gave me a voltage of 5.86 volts. Now I need to get power 1. Power 1 is V1I1. V1 was 1.76 times 0.293 amps. So I got the wattage there to be 0.52 watts. And then I did power 2. And I took V2, 4.4 volts, and multiplied it by 0.293 amps. And when I did that, I got the power to be 1.3 watts. And then I did power 3. which was 5.86 volts times 0.293 amps. And when I multiplied those, I got 1.72 watts. You'll see one like that tomorrow. Alright, and then we need the parallel. So that gave me 9 volts. 12, 25, and 30 were my resistances. So I need to do 1 over RT equals 1 over 12 plus 1 over 25 plus 1 over 30. And so when I did that, I got RT to be 6.38. And then V1, V2, and V3 are all 9 volts. So I1 is 9 over 12, which is 0.75 amps. I2 is 9 volts over 25. So 9/25 was 0.36. And I3 was 9 volts over 30 ohms, which was 0.3 amps. And then I went to power is equal to V times I. So power 1 was 9 volts times 0.75 amps. And that was 6.75 watts. And then power 2 was 9 volts times 0.36 amps. And that power was 3.24 watts. And then the last one was power 3, 9 volts times 0.3 amps. So that was 2.7 watts. Alright, so the format of the test tomorrow is going to be, there are 10 questions that are about statements about the circuits, whether it's a statement that concerns series, parallel, or both. Then there are, I think, 15 multiple choice related to everything else we've talked about. And then there are 5 problems, and then I believe there's a series and a parallel. So that should help you get ready for the test. I'll be in my room early in the morning if you need any help.